Why is JavaScript single-threaded, and what does that mean in practice? JavaScript is single-threaded because the runtime executes code on one main thread that processes one call stack. And this design was chosen to avoid race conditions in the browser, where multiple threads could modify the same DOM tree at the same time, which would cause inconsistent UI state and unpredictable rendering behavior. What exactly exists inside the runtime is a call stack, a heap, web APIs in the browser or Node APIs in Node.js, a callback queue, and an event loop that coordinates execution. And the single thread means only one execution context can be on the call stack at any moment. The order is strict. Global execution context is created first. Then functions are pushed onto the call stack when invoked. The engine executes them synchronously line by line. If a blocking operation like set timeout or fetch appears, it is delegated to web APIs. Once completed, its callback is placed into the callback queue. The event loop checks if the call stack is empty. If empty, it pushes the callback into the stack, and execution continues. Because there is only one call stack, heavy synchronous computation blocks everything. If one function runs for 5 seconds, the UI cannot repaint, user events cannot be processed, and network callbacks cannot execute, which directly affects responsiveness and user experience. Single-threaded does not mean only one thing happens in the system. It means JavaScript execution itself happens in one thread, while I/O operations are handled by the environment, and their results are scheduled back into the single thread through the event loop. So concurrency is achieved through delegation, not parallel execution of JavaScript code. This design simplifies the mental model for a software engineer because shared memory synchronization primitives like mutexes or locks are not required in normal browser JavaScript, but it requires understanding non-blocking patterns like callbacks, promises, and async await to prevent blocking the event loop. In Node.js, the same principle applies. There is one main thread running JavaScript, but libov provides a thread pool for certain I/O tasks, and when those tasks complete, their callbacks are queued back to the event loop. So JavaScript logic still executes sequentially even though the system performs background work. If you need real parallelism, you use web workers in the browser or worker threads in Node.js, which create separate isolated JavaScript threads with their own event loops and memory space. And communication happens through message passing, because shared state across threads would reintroduce race condition risks. In practice, single-threaded means deterministic execution order for synchronous code, potential blocking if CPU-heavy logic is not optimized, reliance on the event loop for scalability, and architectural decisions that separate CPU-intensive work from the main thread. JavaScript is single-threaded to protect shared state like the DOM and simplify concurrency. And in practice, this means one call stack executes code sequentially, while asynchronous operations are coordinated through the event loop, without true parallel execution on the main thread.